Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now in part 2, I want to explain how to know the Lewis-Dot structure, how to draw the Lewis-Dot structure for the molecule or ions. There are steps. The stage for the Lewis structure, we will see first what are the stages here for the Lewis-Dot structure. After that, how to calculate formal charge and what is meant by resonance. Now, stage for Lewis structure, when the formula molecule is given, let us carbon dioxide molecule is given, then what to do? Find the total valency electron. You know what is meant by valence electron, I told before in part 1. And the valence electron means the outermost cell electron. You will CO2, there are 2 oxygen and 1 carbon. You will calculate the valence electron total. That means carbon, that is 4, and oxygen, that is 6, but there are 2 oxygen, 6 into 2, 12 plus 4. So total valence electron, that is 16 for carbon dioxide. The next is first valence electron calculator. Next, put the least electronegative atom at the center. Now 1 carbon, 2 oxygens are there. Now tell me which one is the least electronegative here. I told in the part 1 oxygen belongs to 16 and here carbon belongs to 14 group. That means 14 group elements are less electronegative than 16. That is why in carbon dioxide which one is the least electronegative element? Carbon. Which is the more electronegative element? Between 2, that is oxygen. So what to do? Put the least electronegative atom at the center. That means you will put in center carbon and here oxygen and here oxygen. Here put the least electronegative atom at the center. But if hydrogen present, put the least electronegative atom at the center. Now carbon is the least electronegative compared to oxygen, so carbon in the middle, oxygen on this both sides. But not hydrogen. If in your molecule contains hydrogen, hydrogen never regarded as the rule of electronegative, least electronegative element at the center. Hydrogen is always present on the outer side, not at the center. Put 2 electrons between the atoms. Here see, between the atoms mean here carbon and oxygen. So put 2 electrons between atoms to form a bond. To form a bond means covalent bond, sharing of electron. Now see, here carbon has 4 electrons in outer shell and that is why you leave 4 and oxygen is 6 electrons. See, oxygen having 6 electrons, carbon having 4 electrons. Now try to put 2 electrons between 2 atoms. Now carbon oxygen, here I put 2 electrons to form bond and this carbon oxygen I put 2 electrons to form bonds. Now put 2 electrons between atoms to form a bond. Clear? Then complete the octets on all the atoms. On the all atoms, what are the atoms present here? Carbon, oxygen, and right side also oxygen. Left side, right side, both are oxygen. Now we will try how it will satisfy octet rule. That means 8 electrons in the in your shell. That means here we should check. Now see, the oxygen is 6 electron, oxygen having 6 electron and including these 2, that is 8 electron satisfied. Similarly, this oxygen also 8 electron from oxygen 6 electron, from carbon 2 electron, that is 8 electron satisfied. But when you come to carbon, here only 2 electrons right side, 2 electron left side, that means 4 electrons here, 4 electrons at the center. That means the carbon is not satisfied by octet rule. It has never having 8 electrons up to here. So what to do? Our duty, we should change in this way that all the atoms are satisfied by octet rule. Now complete the octets on the all atoms. Complete the octets on the all atoms. Now we have tried, but carbon is not satisfied by octet rule, but for hydrogen only 2, because hydrogen contain only 1 electron, and here the helium, it will attend the helium configuration, and that is not having 8 octet rule configuration. So here a hydrogen satisfy helium configuration by 2 electron, not by octet 8 electrons. Now, in the central atom does not have octet. If the central atom is, yes, the central atom does not have octet, it has only 4 electrons. Then move electrons from other atoms. So, what are the other atoms here? 1 oxygen right and 1 oxygen left. That means we will move electron from other atoms to the center atom, because center atom is not satisfied by octet rule. Then what to do? Here we will move here these 2 electron move towards it, and these 2 electron move towards it, towards about carbon. That means from oxygen 2 electrons are moved towards our center, that is carbon. Similarly, right side also 2 electrons move from oxygen to carbon. Now see, all are satisfied by octet configuration. Now here, when you take those 2 electrons from here oxygen to carbon, and that side also from oxygen to the carbon, now here oxygen, that is satisfied by octet rule. See, 2, 2, 4, 4, 8, correct, oxygen satisfied. Similarly, carbon, 4 and 4, 8, carbon also satisfied, and that right side oxygen also same 4, 4, 4 to 6 to 8. That means this side also satisfied. But when it is satisfied, then what they will form? They will form double or triple bond. Now here 2 pair of electrons are there for sharing, that is why a double bond. Here also between this carbon and oxygen there are 2 pair of electrons are sharing, for sharing. Here also double bond form. Again see, if central atom does not have octet, move electrons from the outer atoms to form double or triple bond. Automatically the octet rule satisfied. From several Lewis structures, so many molecules are there, polyatomic ions are there, and here several Lewis structures form. But which one is the most favorable Lewis structure? Most favorable Lewis structure, how can you find? Here we need to calculate the formula charge for each atom. Now here carbon in the middle, and right side, suppose left side, that oxygen 1. If we say this is oxygen 1, and yes, and this is oxygen 2, then what happened? Here for oxygen 1 we have to calculate formula charge. Carbon will calculate formula charge, and right side 2, oxygen 2 also will calculate formula charge. Now formula charge, what is mean formula charge? Formula charge means is assigned to an atom in a molecule. When molecule is there, when some charges are assigned to a particular atom. Now in carbon dioxide, 2 oxygen, 1 carbon is there. If for 1 oxygen some charge is given, and for 2 oxygen some charges are given, also carbon charge is given, then what happens? These are called formal charge. Then a formula charge, how can you calculate? How can you calculate? Next we will see. But we know if atoms of the structure having least formula charge. Let us carbon dioxide. Here we have to calculate what is the formula charge. Here also carbon, here also oxygen. We have to calculate 3 formula charge, and if the atoms of structure having least Fc, least means less when compared to other Lewis structure. In compared to other Lewis structure, if it is the least one, least Fc, then that is the best Lewis structure. Suppose there are 4 Lewis structure, then one having the formal charge having least value, then that is the best Lewis structure. Now since there are so many structures are developed, then the resonance structure will come out. What is meant by resonance, I will tell. Now see again, steps for Lewis structure: find the total valence electron first, then put the least electronegative at the center, but not hydrogen. If hydrogen, you know hydrogen the least electronegative atom, but you can't put at the center, that is just exception rule, and here will go outer side. Put 2 electrons between the atoms here, carbon and oxygen, and try to form chemical bond. Complete the octet. Try to complete octet rule. Octet on the all atoms except hydrogen, because hydrogen only 1 electron. So it will try to attain the inert gas configuration of helium, not octet configuration. And if central atom does not have octet, if when you arrange the electrons, if you see the central atom does not have octet, then what to do? Move the electrons from outer side atom, let us here oxygen, move from oxygen towards center and try to form double or triple bond. Now the electrons octet rule, that is octet, that is followed, and now the structure is completed. Suppose in some molecules there are so many structures, Lewis structure are formed, then how can you know what is the best one, which is the best one structure? And for that we need to calculate formula charge. What is formula charge? Formula charge given to a particular atom in a molecule. Now, if atoms are the structure having least, when you calculate formula charge, if it is the least value, and that is the best Lewis structure, and from according to so many Lewis structure form, from that resonance structure develop, and then we will see how to calculate formula charge. Now we will see how to calculate formula charge of an atom. One molecule consists of so many atoms, just like carbon dioxide, here 1 carbon, 2 oxygen. Then how we will calculate the carbon Fc, oxygen 1, oxygen 2 Fc. Now here what is the formula of Fc of an atom, that is formula charge of atom. First, valence electron. How can you know the valence electron? I told, according to group number you can say, according to atomic structure you can find, according to electronic configuration you can find what is the number of valence electron. Next is minus non-bonding electron. Non-bonding electron means the electrons which are not involved in bonding. Just like in carbon dioxide, here carbon, oxygen, let us see, you will calculate oxygen 1, then what is the valence electron of oxygen? That is 6. Here you will put 6. Now what is the non-bonding electrons of this oxygen? Because here it is bonding electron, and these two, that is 4 electrons, that is non-bonding electron. That is why you will put 4 here. Next, minus bonding electrons by 2. Now see, oxygen, these are called non-bonding electron. These 4 are called bonding electron. Now here, this is bonding electron 4 divided by 2. So what is meaning here? Valence electron, that is from the group, you can say atomic structure, configuration, you can say what is the number of valence electron. Non-bonding electron means you will see the structure, the electrons which are not involved to form bonds, that is non-bonding electron. Bonding electron means the electrons which involve in bonding, that is called bonding electron. Now here thermal charge oxygen 1, let it is 1 oxygen, this is 2 oxygen, then I told valence electron 6 minus non-bonding electron, these 2 pair, that is 4, and bonding electron, that is here, these 4 are bonding electron divided by 2, that gives 0. That means this first O1, the charge is Fc is 0. Now Fc of second oxygen, that is O2. Here also same, valence electron 4, non-bonding electron these 2 and these 2, that is 4. Bonding electron these 2 pair, that is 4 by 2, that is equal to 0. That means formal charge of oxygen 1 and formal charge of oxygen 2 are value that is 0. Then come to Fc charge of carbon. We know valence electron that is 4, and here non-bonding electron not present is 8 electrons are involved in bonding electron. So that is why it is 0. Non-bonding electron number is 0. And here bonding electron that is 8 by 2, this is equal to 4, because 4 minus 4 equal to 4 minus 4 equal to 0, minus 8 by 2 that is 4. So 4 minus 4 that is equal to 0. Now you can see here oxygen 0, carbon 0, and next oxygen that is also 0. That means least Fc of each carbon. Here least Fc of each carbon that is 0, that is equal, so it is the least Fc of each carbon is equal to 0. That is why it is the best Lewis structure. That means here from the formula chart we can show that which one is the best Lewis structure. But after that, since there are so many different type of Lewis structures available in some molecules, and then what happened, resonance structure in form. Resonance structure, the word is developed. That means if there are different Lewis structure, out of one which one is the best Lewis structure, and after combination of all the structures, that resonance structure word is used, resonance structure in that is form. If the one of the Lewis structure, if you see, the Lewis structure cannot fully describe the bonding. If it is not fully satisfied, if one Lewis structure cannot describe, cannot satisfy by the describing bonding, what is here bonding, how the bonding is possible or not, and octets are satisfied or not, you will see. If one Lewis structure cannot be satisfied, cannot be described the bonding, then the resonance structure developed. Also, it is also called mesomerism. Resonance is also called mesomerism. By combination of several contributing structure, transfer to resonance hybrid. So many structures are combined, so many contributing structures developed, then here automatically transfer to resonance hybrid structure. Suppose there are 4 or 5 resonance structure developed or Lewis structure that is in the form of resonance structure, and here lastly transfer to one that is called resonance hybrid structure. Now here ozone, you can see one side double bond, one side single bond having negative charge. There are 2 type of resonance structure produced, and after that by combining 2 structures, it transferred to one resonance hybrid structures. Here you can get resonance hybrid structures. Now the gain of stability is called resonance energy. Here it means resonance, what is resonance energy? The gain of stability. All resonance structure having same molecular formula, same number of total electrons, and also net charge, that is Fc also near about net charge same, but what is the difference? Difference is differ by position of pi bonds and lone pair of electron. How the pi bonds are developed, the right side, left side, middle, like this, you will find how the position of pi bond and position of lone pair of electrons, and that is the main difference here. So all resonance structures having same molecular formula, same number of electrons, only difference is position of pi bonds and lone pair of electrons. Again see Fc of atom, how to calculate valence electron minus non-bonding electron minus bonding electron by 2. Non-bonding electron means those are not involved in bonding. Bonding electron means those are involved to form the bonds. In carbon dioxide, these 2 are called bonding electron for this oxygen. These 2 pair also called bonding electron for this oxygen. And these 2 pair, the right side and left side 2 pair, total 8 electrons are also called bonding electron for carbon. for different atom, different bonding electrons are there. So here bonding electrons by 2, that is why carbon here 8 bonding electron divided by 2. Resonance due to different Lewis structure, resonance structure developed from different resonance contributing structure, lastly transfer to resonance hybrid structure. It is also called mesomerism. And next the gain of stability, that is called resonance energy. And here resonance, different resonance structure, what you can find, we find the same molecular formula and same number of electrons, only the position of pi bond and the position of lone pair electrons are different. So in coming video I will explain individual molecule or polyatomic ions, how the Lewis structure is possible and what are the Fc charge, and also how the resonance structure develop and then transfer to resonance hybrid structures. I hope you will just subscribe my channel BL Das, short and sweet in chemistry, and thanks for watching my video.